Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Lalo and I've been guiding you through the chemistry course. In this particular lesson, we'll look at silicon and its compound on very short course. We'll look at silicon, we'll talk about silicon 4 oxide, and we'll talk about the trioxosilicates. Alright, let's go on. Silicon. Silicon is one of the very abundant substances on Earth. It is rich, it is one of the major constituents of the mountains, the rocks, and the land that we see. The landform is made up of silicon, actually silicon oxide, but silicon is part of it. So we talk about silicon, and silicon exists in two basic forms. Some people do like to describe it as allotropes, but we do not describe them as allotropes because they are the same structure. They have the same structure, and the structure is like that of diamond. The silicon types are, some of them are white and some of them are brownish in color. Alright, silicon can be produced in the laboratory by simply burning silicon oxide, carbon in the presence of silicon oxide, and silicon will be separated and carbon dioxide will be produced. Or you can simply react silicon 4 chloride, that's silicon chloride. You can simply react it with zinc and it will form silicon and zinc chloride. So those are the ways to produce it. What are the physical properties? Physical properties of silicon includes it is a non-volatile solid. It has diamond-shaped crystals. It is insoluble in most known solvents. That is, most popular solvents do not dissolve silicon. Chemical properties: it reacts with oxygen to form silicon oxide. It reacts with water to liberate hydrogen and form silicon oxide, of course. It also reacts with alkalis, that's bases. It reacts with them to form to form their salts, which actually are something that produce glass-like materials and liberate hydrogen. Alright, what are the uses of silicon? Silicon is used to alloy some certain materials like brass. You alloy brass so as to give brass the strength. You mix silicon with it while you process it. Also, they are used to make silicones. Silicones are used to make rubber-like glass. So fiberglass and substances like that come from silicon. And then in the making of integrated circuits, of course, since silicon is a metalloid, it makes a very good substance for use for making semiconductors. Yes, it makes very good substance for making semiconductors. So silicon finds its use also in the construction of integrated circuits. Alright, we've said a lot about silicon. Let's take a short break, and after the break we'll be back. In a few seconds, some questions will be displayed on your screen. Please answer them and we'll see you in a jiffy. Welcome back. Let's talk about silicon 4 oxide. Silicon 4 oxide is colorless crystal, has a melting point of about 1500 degrees Celsius. It is created in the laboratory by reacting sodium silicate with hydrochloric acid, or maybe another metallic silicate with hydrochloric acid, and to give you salt and the silica. It's also called silica. It's called silica. It comes usually in the with a water of crystallization. It comes usually with a water of crystallization. So, what are the chemical properties of silica? Chemical properties include it reacts with hydrofluoric acid. Yes, silica is indissoluble. It does not mix. It is insoluble in all substances, all liquids, all acids. It does not mix with water. The only substance where you find it mixing, the only acid you find it mixing with, is the hydrofluoric acid. The hydrofluoric acid, and it mixes with it, forming the compound which appears like a salt and water. It liberates water. Also, if you react it with bases, that is alkalis, it will form the silicate form. That is the substance that you can usually. These particular compounds are found in glass. I won't get to the silicates, that's the trioxosilicates. We'll see more, we'll talk more about them. And it will also liberate water. When it also reacts with other salts, salts of other compounds, as in salts, it will also form the same thing. It displaces the function of the acids in the salts. It displaces them, liberating gases. Even if it is a trioxocarbonate, it will liberate the CO2 from the expression, from the equation. It reacts with carbon on very, very high special conditions where there is very, very high temperature, and it forms a very abrasive substance known as the silicon carbide. The silicon carbide is a very, very abrasive substance. It can be used to scratch and peel off many things. Okay. The uses of silicon oxide, that is silica. Of course, we use silica in the making of silica gel. We also use it in the making of, we use it as a sand in cement making, in glass making, even in concrete making. In fact, it is a major source of our rocks, kind of. It's the major constituents of our rocks. It serves as an insulator. It also serves as an absorbent. Yes, in the gel form, it serves as an absorbent since it is hygroscopic. It attracts a water of crystallization, and also it is used in the preparation of certain chemical compounds. Let's look at the last part of this lesson, which is the trioxosilicates. Trioxosilicates 4s. When we talk about the trioxosilicates, we're talking about the salts of the acid of silicon, the salts of silicon. You know, I mentioned earlier that silicon displaces the acidic functions of salts to replace them. It liberates gases from salts. It displaces even carbon dioxide from salts. So when it replaces them, it kind of forms its own kind of salt. It forms its own kind of salt. But these salts are very abundant in nature. We see them in almost everything we do. In fact, it is what occupies the earth crust. It is what makes up the earth crust. We have them in form of iron triososilicate, magnesium triososilicate, calcium triososilicate, and we do have different names which we do call some of these substances, like jade, like oxyl, like quartz, and the rest of them. Basically, the ones that we are going to talk about more are the sodium triososilicates. Sodium triosilicates find their use in nature in two different ways, two major ways. We'll talk about the silica gel. That is the gel which, if you buy a shoe, you notice that they put something in your shoes, like a bag that contains some tiny stones. It's what's called the silica gel. That glass. It's what's called the silica gel. Now also, there's also what is called the water glass. It's a compound that is made up of sodium triososilicate. Now, this water glass, when it is inserted in hot water, it is meltable at a very high degree, at very high temperature. It would melt, and it can also be rolled out. It is called water glass. Even our conventional glass is made from triososilicates. Our conventional glass, our sand, it is triososilicate. Our clay sand, all this kind of sands you're thinking of, they are all triososilicates. So how do we make glass? We make glass by mixing different types of triososilicates together at very high temperatures between 1,500 and 1,700 degrees Celsius. Between 1,500 and 1,700 degrees Celsius. And after these things have been melted together, they are allowed to cool. Of course, silica melts at about 1,500 degrees Celsius. So when it melts together, they are allowed to cool. And based on the nature of the salts in which they are, the compounds that they contain, they pick up their color. On your screen about now, there is a chart showing different colors that come from different compounds. We see that when you use copper 1 oxide, you have red. When you use copper 2 oxide or cobalt 2 oxide, you have blue. When you have chromium 3 oxide, you have green. When you use manganese 4 oxide, you have violet, and the likes of them like that. So it's also possible for you to create a transparent glass. It depends on the mixture of compounds that you do use. Alright, in this particular lesson, we've learned so much about silica, about silicon and its compound. We talked about silicon as a group group 4 elements rather. Silicon as a group 4 element. We also talked about silicon oxide 4 oxide and silicon trioxosilicates 4. We also mentioned their uses in form of cement, in form of silica gel, and all the rest of them. Alright, in a few seconds, some questions will be displayed on your screen to test your knowledge of what has been taught in this lesson so far. Please do well by answering them. And if there is any part of the question that you do, or any part of this lesson which you do not understand, you can view the video one more time for a clearer understanding. Thank you.